Hello again, Mr. Schlescher from the Quantitative Reasoning Center. Did you know that leadership is not something that just naturally happens in most people? It's something that has to be learned and developed. So that's what we try to do here at the Academy. We don't just slap butter bars on you and say, go be in charge of a bunch of people and a bunch of very expensive equipment. No, we give you small, incremental baby steps to try to get you up to that level. What is your duty today? Well, today your duty is to do your homework, to do various other tasks that are assigned to you throughout your squadrons. So how well you do these small tasks today are going to be a huge determinant in how good you're going to be at being a leader in the future. Okay, so what's your duty today? Do your homework. Let me help you out here a little bit. Here's one of the homework problems we had for today. This is problem 26 from section 9.1. We're given a bunch of sequences and we're asked to find out what happens to these sequences, what's their end behavior as n approaches infinity. Well, you may notice I've changed mine just a little bit, but they'll be solved the same way when you do yours. So some of them may look real close and some of them are off by a little bit. So here we go. First one, S sub n equals n times quantity n plus 1 minus 1. What happens to this thing as n approaches infinity? Well, let's do a little bit of algebra here first. Make things look a little easier. Now let's call it n squared plus n minus 1. That looks a little better. Now, the limit as n approaches infinity of this thing, I can see this one's pretty obvious. That's going to get super huge, that's going to get huge, and then I'm only subtracting one off of it, so obviously this thing is going towards infinity, and that would be positive infinity. Okay, that was too easy. Let's try one that gets a little bit more difficult here. Okay, S sub n equals 1 over n plus 2. Okay, what is the limit as n approaches infinity? Now, we can see here that I'm going to end up with a 1 over infinity kind of situation here. Alright, so let's just take a look and see what happens with this thing. We start out with 1 over 3 because we start with n equals 1 and work our way up. The next one in the sequence would be 1 over 4. Next would be 1 over 5. I'm noticing a trend here. Once I get out here to say 1 over 2014, I notice that number is getting really, really small. And in fact, it continues to get smaller. And this thing does equal, it goes towards 0. And it goes through to 0 through, we can see they're all positive numbers. So it goes to 0 through positive numbers. Okay, that's too easy. Let's get a little more challenging, shall we? Okay, let's take a look at this one up here. S sub n equals 1 minus n cubed. Okay, if I take the limit as n approaches infinity, I can see that I'm going to start out right off the get-go when n equals 1. I'm going to start out at 0. That one's that's a pretty good indication there what's going to happen to this one. Next number, 2. That becomes a negative 8. 1 minus 8 is negative 7. And it only gets worse. And this thing does approach negative infinity. I'm just going to get smaller and smaller. There's no change in that one. Okay. Let's take a look at this one. Get rid of some extraneous information there. S sub n equals sine of 1 over n. Okay, so what happens with a sine function? We know that since, let's take a look at this little piece right here. Let's look at the limit of 1 over n. 1 over n as n approaches infinity. Now we can see from very similar to this one over here that this thing is going to go towards 0. 1 over a very large number is 0. So basically I'm looking at sine of 0. And what is the sign of 0? Obviously it's 0. So this thing goes towards 0. Okay, now let's take a look at this one over here. This one's interesting. I have the sequence cosine n over n. Okay, cosine of n. Now that's an interesting function. We know we can graph this thing, and cosine does this. As n approaches infinity, it's just going to keep doing that all the way out. Okay, so it goes from 1 to -1 back and forth. Okay, but now let's take a look at this divided by n thing under here. As n approaches infinity, in fact the limit as n approaches infinity of this whole thing, let's just look at the 1 over n part. Okay, that's going to go towards 0 as we've seen before. We just have 1 over a very large number, which of course is 0. But how does it get there? That's the important part in this one. We can see that this thing is going to go towards 0, but it's going to get there not by a direct route. It's just actually by dividing this by n. Essentially what we're doing to our cosine function is we're getting smaller, 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 and we know that it goes towards 0 because of this n under here, but the way it gets there is it goes towards 0, but it goes through positive and negative numbers. Isn't that fun? Okay, so these are all fun to look at, and they all are different. So have a blast. Enjoy.